Welcome to this explainer. If you're building or working with a high-power AI workstation, well, you already know the pain. You've got this absolutely incredible, powerful local inference rig, but sitting next to it, it literally feels like you're sharing your desk with an F-15 fighter jet spooling up for takeoff. It's hot, it's loud, and honestly, it's incredibly distracting. Naturally, you want to fix it. But I'm going to tell you right now, your very first instinct on how to silence that machine is likely completely backward. Okay, let's dive into this and completely rethink exactly how we handle workstation noise.
So picture this, your rig is spinning up, the fans are absolutely screaming, and the noise is driving you crazy. What is the very first thing almost everyone does? They jump online and they buy acoustic foam. They want to line the inside of the case, line the walls near the desk, just stick foam everywhere. It feels like the right move, right? But relying on foam as your primary weapon against the loud workstation is actually a massive mistake.
And here's the harsh reality of the whole situation. Acoustic foam is dead last. On the hierarchy of effective acoustic treatments for high-power rigs, foam sits firmly at the absolute bottom of the list. It's the thing people reach for first, but according to the source material we're looking at today, it is absolutely the thing you should reach for last. To understand why, we need to look at how sound actually works and how we should be prioritizing our interventions.
Let's walk through the true hierarchy of acoustic treatment. At step 4, the very top of the pyramid there, that's absorption. That's our acoustic foam. It's actually the weakest link. Moving down, step 3 is blocking transmission with a heavy barrier. Step 2 is source reduction, which means making the PC itself quieter through things like undervolting or better fans. But step 1, the ultimate king of soundproofing, distance and isolation. Moving the rig away from you is vastly more effective than anything else on this list.
Let's get into the physics breakdown, airborne versus structure-borne.
To truly grasp why that hierarchy is laid out the way it is, and why our beloved acoustic foam fails us so often, we need to quickly break down the physics of noise into two distinct categories. Because think about it, if you don't know what kind of noise you're actually fighting, you're going to use the wrong weapon. On one side, we have airborne noise. This is exactly what it sounds like, the whoosh of the fans, and that high-pitched GPU whine traveling directly through the air to your ears. Structure-borne noise, however, is a physical vibration. It's that low-frequency hum transmitted from the machine directly into the solid wood of your desk, or down into the floorboards, literally turning your entire room into a giant speaker cone.
So the absolutely crucial point here is this. Foam absorbs, but it does not block. This is the ultimate limitation of acoustic foam when fighting airborne noise. Foam is going to soften the echoes within a reverberant room, making the space sound less harsh. But it will absolutely never stop sound from passing right through a wall. If your rig is bleeding noise out into the hallway, sticking foam on your wall does nothing. To stop noise from leaving a space, you need mass. You need a solid barrier, like a heavy door, not lightweight foam.
But what about that structure-borne noise, that annoying desk-shaking hum? For that, we use mechanical decoupling. This is simply the use of anti-vibration pads, rubber feet, or grommets placed between the machine and the surface it's sitting on. You're physically breaking the solid connection so those low-frequency vibrations can no longer travel from the computer case into your desk.
I honestly cannot stress enough how incredible this simple trick is. Rubber feet kill the hum that foam never even touches. You can spend hundreds of dollars lining a room with premium acoustic panels, and you're still going to hear that deep, desk-rattling hum. Or you can spend literally just a few dollars on a pack of rubber anti-vibration feet from Amazon, slide them under your PC tower, and completely eliminate that structure-borne noise. It's a real game changer, easily the single highest value, cheapest fix in the entire soundproofing playbook.
So let's look at strategy 1, just move it.
Now that we understand the physics of the noise we're dealing with, let's talk practical deployment strategies. The ultimate highest value move available to anyone building a local AI inference rig is incredibly simple, yet it's routinely ignored. Consider this simple truth. You don't actually need to sit next to an AI workstation. Think about how we generally use these machines. A local inference rig is something we talk to over a network. You SSH into it, you hit a local API endpoint, or you point your laptop's interface at it. The machine executing the heavy workloads and the machine you're physically typing on, they don't have to be the same device.
And this leads us to the ideal setup, which we call the Mac and Fleet workflow. You keep a totally silent, cool laptop, like a Mac, right there on your desk for your daily driving. Then, you take that roaring, heat-dumping GPU tower and you put it in another room entirely, a spare bedroom, a basement, wherever. You connect to it via SSH or an API. Done this way, the rig's acoustics literally stop mattering. It can be as loud as it wants, and your workspace remains completely silent. Distance really is the ultimate soundproofing.
Moving on to strategy 2, the rig in the closet setup.
Of course, not everyone has a spare basement, right? Which makes a nearby closet a super popular alternative. You just stick the loud machine in there, shut the door, and boom! Sounds like a perfect, easy solution. But there is a very dangerous catch you need to know about before you try this. 600. That's the number you need to keep in your head. A high-powered GPU tower easily dumps 600 watts or far more of continuous heat while running an AI workload. When you place a machine pulling that kind of power into a closet, it's no longer just a computer. Functionally, it's acting exactly like a literal 600-watt space heater running at full blast.
And that brings us to the crux of the problem. Trapped heat cooks a 24/7 rig. If you put a sustained load machine into a sealed, unventilated closet, it's going to rapidly raise the ambient temperature of that tiny space. Within an hour, the machine is forced to pull its own hot exhaust back into its intake fans. The hardware will overheat, aggressive thermal throttling will kick in, and those fans, they'll roar even louder, completely defeating the purpose of hiding it in the first place.
So here's the absolute golden rule for any enclosed workstation placement. It must breathe. You can't negotiate with thermodynamics. If you trap 600 watts of heat in a box, that heat has to have somewhere to go, or your expensive hardware is going to suffer big time. Let's look at the strict rules for successfully pulling off a closet rig without frying your gear. First, it requires active ventilation. At a minimum, you need a quiet exhaust fan actively pulling the hot air out of that closet and drawing cooler air in. Second, never fully seal a high-powered rig without some form of thermostat control. And third, you must monitor the ambient temperatures constantly. If that closet warms up, your GPU is choking.
Now, if you want the ultimate enclosed solution, look at this number, 36. Purpose-built, soundproof server cabinets exist precisely to solve this problem, and they can suppress up to 36 decibels of noise. They are the engineered answer. They combine acoustic lining with heavy barrier walls, and crucially, they feature built-in thermostat-controlled exhaust fans. They safely dissipate kilowatts of heat while dropping the noise floor drastically. Yeah, they're an investment, but for sure, they're the right way to enclose a rig.
And finally, strategy 3. Treat what's left. But hey, let's say you can't move the rig to another room and you can't put it in a ventilated closet. If you are absolutely stuck keeping this machine right there in the exact same room with you, here's the correct order of operations for in-room treatment. Step 1, decouple. Get those cheap rubber pads under the case immediately to kill that desk hum. Step 2, absorb. Now you can use acoustic foam on nearby hard surfaces to soften the harsh, high-pitched reflections bouncing around the room. And step 3, block. If noise is bleeding out your door and bothering someone else in the house, hang a dense sound barrier blanket or install a heavier solid door to stop that transmission. You gotta match the treatment to the exact problem.
As we wrap up, I want to leave you with the absolute core takeaway from our source material today. The most powerful noise lever isn't a material, it's a floor plan. I love that. It perfectly summarizes everything we've talked about. Spatial planning and distance will beat expensive acoustic foam and gear every single time. Putting a wall between you and the machine, that is the ultimate hack.
So, I'll leave you with this provocative question to ponder for your own setup. Are you actually trying to silence your machine, or are you simply sitting too close to it? It's time to rethink your workflow. Stop fighting physics with cheap foam and start using network architecture and distance to your advantage. By doing so, you can enjoy all the insane power of local AI without ever having to actually hear it. Thanks so much for joining me on this explainer, and I'll catch you on the next one.